So what are we going to talk about today?
Let's see. So let me get all my stuff together. So we're talking about converting degrees to radians and stuff like that.
Okay.
Would you like me to send you a picture of a few things, or
You can, if they're difficult to verbalize. If they're easy to verbalize, it's just easier to verbalize.
Okay, I'll just verbalize a few.
Okay.
So the first one is sine 150 degrees. It says to find the exact value.
Okay. Hold on. 1 moment. Okay. You and I haven't talked about the unit circle.
No, we haven't.
We need to. Those are the 4 quadrants.
Okay.
You want to memorize all of the first quadrant trig functions. The standard ones. In other words, 30 degrees, 45 degrees, and 60 degrees. Those are what you're going to be dealing with, and multiples of those when you talk about angles that are in the second, third, and fourth quadrant. So, let's memorize the first degree ones. And the best way to do that is by our standard special triangles. Still there, Connor? Connor? Lost you. Let's see what happened here. It is. We can hang the phone up.
All right.
Okay. And you can see my screen okay?
Yep.
Okay. So, using these 2 triangles, which are triangles that you've dealt with for 3 years now, the 30-60 right triangle and the 45-45 right triangle, if you... now my pen doesn't work. Hold on.
Yeah.
That means I'm going to have to redraw everything I did. Yeah. All right, here. Let's start with these 2 triangles. This is kind of the beginning place for trig. You need to memorize the dimensions on these 2 triangles. I call them my unit special triangles, and I call them that for a reason, because the side opposite the smallest angle is always 1. Even though that's also 45 there. And on the 30-60, the side opposite the 60 is square root of 3, and the hypotenuse is 2. On the 45-45, that one's also 1, and this is square root of 2. So if you memorize everything you see on my page right now, you will have the first quadrant memorized. So what's the sine of 30 degrees?
Of 30, would that be using the two triangles?
Yeah, you also need this.
Oh, okay.
Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So
would it be
sine of 30?
1 over 2?
Yeah. What would the sine of 60 be?
Would it be 2 over 4?
Opposite to 60. What's opposite to 60?
Oh, the square root of 3. I see. Okay.
Over the hypotenuse. In other words, in this SOHCAHTOA, there's a hidden over right there. In all three of them. In other words, the O is opposite, the H is hypotenuse, the A is adjacent. And then, of course, it's the sine is opposite over hypotenuse. So what's the tangent of 45?
That would be 1 over 1?
Correct. And the sine of 45?
That would be 1 over square root 2.
And then rationalize that for me. In other words, you don't ever want to have an irrational number in your denominator. It's not like dividing by 0. This is still the same number as I'm going to get after I rationalize it. It's just they don't like answers with an irrational number in the denominator. So if you multiply this 1 over root 2 by, I can multiply it by the number 1 without changing its value. So I'm going to multiply it by that 1, and I get root 2 over 2. Okay? So, using these two triangles, memorize everything you see here. You can now do all 6 trig functions. Okay, what is the cosecant of 30 degrees?
Cosecant. Is that 2 over 1?
Yeah. In other words, the only thing you need to memorize is that cosecant is the reciprocal of sine. And secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So if you memorize SOHCAHTOA and these two triangles, you will have all of the first quadrant angles for 30, 45, and 60. You with me?
Yep.
Okay, now let's go and look at second quadrant and third and fourth quadrant. This is 1, this is 2, this is 3, this is 4. And this is 90 degrees, this is 180 degrees, this is 270, and this is back to either 0 or 360. Now, if we are in the second quadrant, we also know that all students take calculus. All 6 trig functions are positive in the first quadrant. In the second quadrant, only sine and its reciprocal are positive, which would be sine and cosecant. We don't list that because we assume that you know that if sine is positive, the reciprocal has to be positive. Also, to convert second, third, and fourth quadrant into a first quadrant angle, in the second quadrant, we use 180 minus theta. In the third quadrant, we use the opposite, theta minus 180. And in the fourth quadrant, it's the same as the second, only instead of 180, it's 360. Okay?
Okay.
So, now let's take the problem. Sine of 150 degrees. What is the equivalent first quadrant angle? Plug it into this.
Oh, okay. Is it 30 degrees?
Yeah. So that's kind of like saying the sine of 30. What's the sine of 30 based on these triangles?
That is 1 over 2.
Okay. So our answer is 1 over 2. Now we just need to put a plus or minus sign on it. Well, what is sine in the second quadrant? Is it plus or is it minus?
That's minus. Or plus.
Right, because of that. Okay, so the answer is plus 1/2. Now, between this picture that you see and those two triangles, you can figure out the trig function of any angle. Do you have another one?
Yeah.
What is it?
There's cosine of 240 degrees.
Okay, which quadrant's that in?
Fourth.
No.
No?
Between 180 and 270.
Oh, yeah. So then third.
Okay. So what's the equivalent first quadrant angle based on that formula right there?
60 degrees.
Okay, so we're talking the cosine of 60. What is that based on those two triangles?
1 over 2.
Yep. So the number is going to be 1 over 2. Now we just have to put a plus or minus sign with it. What's the plus or minus sign going to be? Is it going to be plus or minus?
Minus.
Correct. So the cosine of 240 degrees is minus 1/2. And that's the way you're going to do every one of these problems. So what you need to memorize, in other words, I know that in school they give you this huge circle and they break it up into 16 points and they say memorize all of these points, right? Have you had to do that yet?
Yeah, I think so. Yeah, we just
doing now. Well, that's silly. Nobody can memorize that. In other words, here's what I'm talking about. Here's what they typically try to get you to do. Is they break up the unit circle into the 30, 45, and 60, and then they keep going. And they end up with 16 different things they want you to memorize. And nobody can memorize 16 things. If I gave you a 16-digit credit card, you wouldn't memorize it as 16 digits. You would memorize it as 4 series of 4 digits each, right? Kind of like the way you memorize a phone number. You don't memorize all 10 digits. You memorize the area code, and then you memorize the first 3 digits, and then you memorize the next 4 digits. So it's much easier to memorize stuff in groups of 3 or 4. So rather than memorizing this entire circle, all 16 points on it, for sine, if you include all 6 trig functions, there's actually 96 things to memorize. Well, that's silly to try to memorize it as 96 different things. But notice there's only 3 things to memorize in that triangle. There's only 3 things to memorize in that triangle. And there's only 3 things to memorize in SOHCAHTOA. And finally, there is 3 things to memorize there, depending on the quadrant you're in. And there's 4 things to memorize here. So between memorizing stuff of 3 and 4 groups, we can come up with the trig function of any angle that is a multiple of 30, 45, 60, and 90. And we'll work with the quadrangles next. But so what's your next problem?
Let's see. I have sine of pi over 4.
All right. So if we're dealing with radians, then we got two choices. We can convert to degrees and do everything in degrees, or we can work with radians like it's a foreign language. Eventually you start thinking in the foreign language. This becomes pi minus theta. This becomes theta minus pi. And this becomes 2 pi minus theta. So, and this is 3 pi over 2 instead of 270 degrees. Okay? So now you have everything you need to do trig functions if you memorize what you're looking at. So pi over 4, do you know what angle that is?
Is that 45 degrees?
In other words, we're going to multiply it by 180 over pi to convert it. 180 divided by 4 is 45 degrees. But at some point, if you do trig long enough, you know that pi over 4 is 45 degrees. Okay? So you don't actually have to convert it. All you have to remember is what is the sine of 45 degrees? Well, I'm going to keep showing you these triangles all day today, but at some point you're going to have to memorize these triangles. What's the sine of 45 degrees?
That is 1 over square root 2.
Okay, and how should we express that?
Square root 2 over, or square root 2 over 2. Square root 2.
And just for your information, 1 over square root of 3 is 3, it's square root of 3 over 3. 1 over square root of 5 is square root of 5 over 5. You get the pattern?
Yeah.
Okay. So it's pretty easy to rationalize the simple ones without doing any math. Okay? So this is the number. That's the answer. Which quadrant is it in?
That would be
Pi over 4. First quadrant. So it's positive. All 6 trig functions are positive in the first quadrant. That's what the A means. Okay?
All right.
Okay, what do you got next?
Then it says evaluate and then write in radical form sin 60 degrees plus cosine 30 degrees.
Sine of 60 degrees plus cosine of 78 degrees?
30 degrees.
Of 30.
For cosine.
Okay. You know what? Before we go on to those, let's make sure you're perfect at this. Let me make some up for you. Because there's nothing more important in trig than being able to do this without a calculator. If you had to know one thing and one thing only in trig, it would be this, the unit circle, and how to do it. So let me make some for you. What is the tangent of 210 degrees?
Okay, so that would
First thing, identify the quadrant.
That would be in the third quadrant?
Correct. Okay, now what is the equivalent first quadrant angle?
Mean for 210 degrees? That's 210 minus 180?
Correct.
Okay.
That's the way we're going to do it. So it's going to be the same absolute value as the tangent of 30 degrees. Well, let's go back and look at our two triangles. What's the tangent of 30?
That's opposite of or adjacent, so 2 over square root 3.
Opposite is 1. Adjacent is square root of 3.
Okay.
So the tangent of 30 degrees is 1 over square root of 3. Rationalize that.
Square root of 3 over 3.
So that's the number for the tangent of 210. It's square root of 3 over 3. Now let's figure out what its sine is. Is it plus or minus?
It is plus.
Exactly. And that's the way we're going to do all of these. Okay. What is the sine of 240? Which quadrant?
Fourth.
This is 270, this is 180.
Third.
Okay, so it's third, which means it's the equivalent of the sine of what? The
60.
Right. Okay, what's the sine of 60 based on these two triangles?
Square root of 3 over 2.
Correct. So the sine of 60 is square root of 3 over 2, and then what is its plus or minus sign?
That's a minus.
Correct. And that's the way you do them, no matter what the angle. Let's do a harder one. Let's do, whoops, I erased something I didn't mean to erase there. Okay, let's do the sine of 390.
Okay. So I guess I'd be in the first quadrant?
Correct. In other words, the first thing we're going to do is convert it to an angle that's inside the unit circle. So it's the same as the sine of 30. So we know that's 1/2. Okay, now let's talk about negative angles. What is the sine of minus 30 degrees? In other words, positive angles are measured counterclockwise. Negative angles are measured clockwise. So they're talking about that angle right there.
Oh, okay.
Okay.
So would it be 330 degrees?
Yeah, that's the hard way to do it, but you're right. Let's do it that way. So, and I'll show you why that's the hard way. But this is the way I always used to do it. So what's the sine of 330? What's the equivalent first quadrant angle?
I'm not exactly sure. Oh, so with
Use that formula.
Oh.
360 minus 330. So that's should be.
Oh, so that's just 30 degrees.
It's the sine of 30.
Oh, okay.
Okay.
So then,
what's the sine of 30?
1 over 2.
And what is its plus or minus sign in the fourth quadrant for sine?
Minus.
That's it. Okay? So that's the hard way to do it. Let me show you the easy way to do it. Remember odd and even functions? Sine is odd, meaning the sine of a minus angle is the same as minus the sine of the angle. So is tangent. Tangent is odd. And when I say sine and tangent, I also mean they're reciprocals. So also cosecant and cotangent are both odd. And finally, there is one even function that's a trig function, and that's cosine. And remember that when you have an even function, when you evaluate it at negative x, it's the same as positive x. See the difference in those three? Okay, so our problem was the sine of minus 30 degrees, right? So if we use that property, then I don't need to convert it to a 330 degree angle and then the equivalent first degree angle. I can just say that that's the same as the sine of 30 minus the sine of 30. Well, I know that that's 1/2, so I instantly get to the answer without having to go through a 330 degree angle and then that equals a 30 degree angle. You see what I'm saying? Okay? So you want to memorize that stuff. Trig is all about memorization. It really is. More memory required in trig than any math prior to that. So memorize the odd even of your 3 primary trig functions. And it's pretty easy because the only one that's even is the cosine of minus x. So what is the cosine of minus 60 degrees?
It's the same as cosine of 60 degrees.
Which is?
So, 1/2?
Yeah. Notice that the sine of 30 is equal to the cosine of 60. Let's talk about that. We have our cofunctions. Have you come across cofunctions yet?
Not really, no.
Cofunctions are very easy. The cofunction of sine is cosine. In other words, you take the trig and you stick a co in front of it. That's your cofunction. Well, cofunctions have a certain property. This is it. Likewise, the cosine of x equals the sine of pi over 2 minus x. Notice that the sine of 30 degrees is the same as the cosine of 90 minus 30, or 60. So it's not accidental that the cosine of 60 was the same as the sine of 30. And the other cofunctions, well, the obvious one is tangent and cotangent, have the same property. And in reverse, and finally, the last two are secant and cosecant. Those are cofunctions. Not to be confused with reciprocal. Notice that the reciprocal is not the same as the cofunction, except with tangent and cotangent. In other words, these two are not only cofunctions, they're also reciprocals. But the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. Okay. So that just means that when you see the cosine of 60, if you have the sine of 30 memorized, you can draw instantly from that. So the cosine of 60 is always going to be the same as the sine of 30. The sine of 20 is going to be the same as the cosine of 70. Okay? All right, let's go back to your problems. What's next? I don't want to get ahead of myself here. I want to follow your problems, but I'm quite sure that at some point you're going to have negative angles and cofunctions.
Let's see. It says sine of 60 degrees plus cosine of 30 degrees.
Okay, we know these two are going to be the same, right? From what we just talked about. So what's the sine of 60?
It's 1/2.
Look at the triangle again.
Sorry. It's square root of 3/2.
Okay, so this is square root of 3/2, and it's a plus because it's first quadrant. And the cosine of 30 is?
Negative square root of 3?
Same thing. Square root of 3 over 2. It's in the first quadrant. All trig functions are positive in the first quadrant.
Oh,
Okay? So if you have square root of 3 over 2 plus square root of 3 over 2, what is that?
Square root of 3?
Correct. So that's the answer. Okay, what else you got? Let me work down here. I got a little more room here. Yeah.
Cosine of 30 degrees times sine of 135 degrees minus sine of 45 degrees times cosine of 210 degrees.
All right. Each of these needs us to identify what each one is. Well, what's the cosine of 30?
That is 1 over 2.
Look at the triangle.
Or, sorry, square root of 3 over.
Yeah, it's worth memorizing sine and cosine for these two angles right here, and this one, 45 degrees. And I mean, memorize those as opposed to memorizing these triangles and being able to figure out those. But the one thing you end up memorizing fairly quickly, just because you come across it so much, is the sine of 30 is 1/2, the sine of 60 is square root of 3 over 2, and the sine of 45 is square root of 2 over 2. Even though it looks like 1 over square root of 2, that rationalizes to that. Okay? So it wouldn't be a bad idea for you to memorize these just on their own, aside from the triangles. Just because you have to come up with that answer so much.
Okay.
So, cosine of 30 was square root of 3 over 2. Now, what's the sine of 135? We need to go back and look at our unit circle. What quadrant's that in?
135? That's in the second quadrant.
That's always the first step, is figure out what quadrant it's in. Okay? Since it's in the second quadrant, what is its equivalent first quadrant angle?
That's 25 degrees.
45. 180 minus 135. Okay, so it's 45. Sine of 45 is what again?
It is... Oh, sorry. 1 over square root of 2.
Okay, rationalize that.
Square root of 2 over 2.
Okay, so the sine of 135 is square root of 2 over 2, and what's its plus or minus sign?
It's plus.
Good. Okay, so we got this number and we got this number. Now let's subtract. What's the sine of 45 again?
It's 1 over square root of 2.
Which is square root of 2 over 2. And now we need to figure out the cosine of 210. Well, what angle or what quadrant is 210 in?
210, the third quadrant.
Okay, so what's its equivalent first quadrant angle?
210 minus 180, which is 30.
What's the cosine of 30?
It is square root of 3 over 2.
But in the third quadrant, what's its plus or minus sign?
It's plus.
All students take calculus. T is the third quadrant. So if it's not tangent, it's minus. That's what these mean. In other words, A stands for all, S stands for sine, T stands for tangent, C stands for cosine. So cosine is positive in the first and fourth. Tangent's positive in the first and third. Sine is positive in the first and second. So this is cosine, so it's negative. So I got to stick a negative sign in front of that square root of 3 over 2. Okay? Now the problem is square root of 3 over 2 times square root of 2 over 2 minus a minus, which is the same as plus, square root of 2 over 2 times square root of 3 over 2. So what is that equal to? Multiply numerators and denominators.
2 square root 2 times...
If I multiply square root of 3 times square root of 2, that's just square root of 6.
Oh, okay. So it was square root of 6 over 2?
Over 4. You got to multiply the denominators also. We're multiplying, not adding.
Okay.
Plus, that's the same thing, square root of 6 over 4. So if I have one of those and I add one of those, I got 2 of those.
So 2 square root 6 over 4.
Which simplifies to square root of 6 over 2. And there's your answer. And they said leave it in radical form, meaning do not convert the square root of 6 to a number.
Okay.
That's what they mean by that. Okay, just because square root of 6 is the most accurate. In other words, if I want the most accurate possible description of this, it's square root of 6 over 2. It is not the decimal you would come up with if you looked that up in your calculator. The decimal is an approximation. There's no way to write that any more accurate than square root of 6 divided by 2. That's why they want you to leave it in radical form. All right. What else you got? The unit circle is so valuable that every time I give a Trig 101 lesson, I always leave it there. Okay? Because you need to memorize everything you see on this page right now. Notice that this 180 minus theta means the same thing as pi minus theta. But if the problem is in radians, you can use this. Let's do one. What's the sine of 2 pi over 3? What quadrant's that in?
That would be in the first quad, or no?
This is pi over 2. This is pi.
Okay, so then it's in the second quadrant.
Okay, because it's in the second quadrant, I'm going to use that. So pi minus 2 pi over 3 is pi over 3. So there's its equivalent first quadrant angle without having to convert to degrees first. Okay? Now, whether you have this memorized or not is a different story, but what angle is that? At some point, we all tend to convert it to degrees. It's just a question of at what point. Pi over 3 is which angle?
That would be...
I'll give you a quick hint. Not a hint, but a tip. These always multiply to 180 as long as it's just pi in the numerator, not 2 pi or something. So to convert pi over 3 to degrees, just make sure this one times that is 180. So it's always 60 degrees. Pi over 6 would be 30 degrees. Pi over 4 would be 45 degrees. Okay? So, what's the sine of 60 degrees?
That would be square root of 3 over 2.
Yeah, you're getting it now. So the answer to this is, we know it's square root of 3 over 2, and what's the plus or minus sign of the sine in the second quadrant?
What was that?
What is the plus or minus sign? It's difficult to talk about trig because sine has two different meanings, S-I-G-N or S-I-N-E. So whenever I'm talking about it, I have to say, what's the plus or minus sign?
Okay.
What is sine in the second quadrant? Is it plus or minus?
Plus.
All right, so it's plus. And that's the answer. And we went through degrees, but not immediately. We didn't convert this to degrees. We worked with this instead. And then once we got it to a first quadrant angle of pi over 3, you'll get to a point where you'll memorize what pi over 3 is also, and you won't have to ever go through degrees. At this point, it's tough because, well, trig is like a foreign language to begin with, and then it has degrees and radians, so it's almost like translating two foreign languages. You know what I'm saying? Yeah. So it's tough, but eventually you'll memorize that, whether you try or not. You'll memorize it. It'll sink in by osmosis. All right, what else do you got?
I have sine squared of pi over 2 plus cosine squared of pi over 2.
There is a trig identity. It's called a Pythagorean identity that says that no matter what the angle is, if I take sine squared and I add cosine squared to it, it's going to be 1. So no matter what angle you would have given me here, the answer is 1. It could be pi over 2, it could be pi over 4, it could be pi over 6, pi over 3, it could be 20 degrees. Sine squared plus cosine squared is always 1. That's an important identity. That you definitely want to memorize that. That's even something that you need to take the ACT test in Colorado. That's something they expect you to know. Okay? However, let's go through and prove it. Well, first of all, let's talk about the quadrangles. So far, the only thing we've talked about are multiples of 30, 45, and 60. We haven't talked about the quadrangles. The best way to handle the quadrangles is to memorize the two curves. That's the sine function. Not only memorize the two curves, but memorize everything you see on here. With these functions, there's always 5 key quarter points, is what they're called. And notice that at the first quarter point, sine of 0 is 0. Sine of pi over 2 is what? What's the sine of pi over 2 based on my graph?
Oh, 1.
Okay. What's the sine of 3 pi over 2?
Negative 1.
Okay, now I'm going to draw the cosine curve. Cosine curve is different. It starts at 1 and goes down to negative 1, but the quarter points are the same. They're still pi over 2, pi, 3 pi over 2, and 2 pi, back to the beginning. So what's the cosine of pi over 2?
That would be 0.
Okay, so let's go back to our problem. The sine of pi over 2 was 1. Squared is still 1. Plus the cosine of pi over 2 is 0. Squared is still 0. So 1 squared plus 0 is equal to 1. And no matter what angle you would have given me, it's still going to equal 1. We can do it manually, individually like this, or we can know that it's called the Pythagorean identity. There's 3 of them. And they're going to, at some point in trig, they're going to want you to memorize all 3. But the most important one is sine squared of x plus cosine squared of x is equal to 1, no matter what x is. Let's go back and look at our quadrangles. What is the sine of pi?
0.
Okay. You'll notice that each one of these, that's 90 degrees, that's 180, that's 270, that's 360. So this is what are called the quadrangles, the multiples of 90. And you can't really get these from these 2 triangles. I mean, you can, but it takes a little bit of out-of-the-box thinking. And it's not the best way to get them. The best way to get them is to know the curves, because you got to memorize these anyway. You want to have these memorized. You want to be able to recreate these 2 curves from scratch. Now, I've only drawn 1 period of each of these. In theory, this thing just keeps going, both directions. Same with cosine. Okay? But the most important part is that 1 period, this period right there, because this gives you all of the answers to all of your quadrangles, and for that matter, anything else. In other words, I know that there's pi over 4, right?
Mm-hmm.
So the sine of pi over 4 is right there. Well, we know the sine of pi over 4 is square root of 2 over 2, and that is approximately 0.7. Well, that's where that is right there, 0.7. So this curve shows you all of the values, but the most important values it shows you are the quadrangles, because you can't get the quadrangles from those 2 basic triangles that I've asked you to memorize. So memorize these 2 curves, everything you see on it.
Okay.
And the x-axis here is usually written in radians, not degrees. It just is. Once you get into trig, the deeper you get into it, the more stuff is in radians. The reason is that when you get to calculus, calculus only works if everything's in radians. It doesn't work if it's in degrees. So you need to be in radians to do calculus. Okay, so that's why radians, that's why they have you memorize them, and you can't just always stay in degrees. All right, what else you got for prop?
Let's see. I
have like
have
4 minutes, and unfortunately I
Okay.
have a 1:30, so I got to run at 1.
Okay. I'll try and find a shorter one.
You might be able.
Sine.
Go ahead.
What?
Yeah, go ahead.
Sine of pi over 4 plus cosine of 3 pi over 4.
All right. We just want to do these individually. There's no Pythagorean theorem. There's no Pythagorean identity that applies here because it's not sine squared or cosine squared. So what's the sine of pi over 4? Let me take you back to the 2 triangles. Which one is pi over 4? Which angle?
That would be 45 degrees.
Okay, so the sine of pi over 4?
That is 1 over square root of 2.
Which is?
Which, square root of 2 over 2.
Okay. Now, 3 pi over 4.
That would be...
Always identify the quadrant first.
Oh, okay. So, that would be in the first, or the...
This is pi over 2.
Uh,
This is pi. This is 3 pi over 2.
oh, okay.
So where's 3 pi over 4?
The third quadrant.
Second.
Or second
Notice that 3 pi over 4 is less than pi, but greater than pi over 2. That's how you do it, basically. Is figure out if it's greater than or less than pi to start with, and then place it in the proper quadrant. So 3 pi over 4 is in the second quadrant. What is, using this, what is its equivalent radian first quadrant angle?
135 degrees.
Well, okay, you converted it to degrees immediately. That's okay. Nothing wrong with doing it that way. So what's its equivalent degree first quadrant? In other words, use this, since you converted it immediately.
180 minus 135. And then that would be 45 degrees.
And what's the cosine of 45?
That would be 1 over square root of 2.
Okay. So that's equal to 1 over, or square root of 2 over 2. And what's its plus or minus sign in the second quadrant?
Negative.
Okay. So, get back to our problem. We have square root of 2 over 2 plus a minus square root of 2 over 2.
That's 0.
Okay, and that's the way you want to do all of them. We could have done that other one that way also, but it's nice to recognize a Pythagorean identity. In other words, the sine squared of pi over 2 plus cosine squared of pi over 2. We didn't care what the angle was. As long as I'm looking at sine squared plus cosine squared, I know that's 1. All right. That's probably a good place to stop.
Yeah.
Let me remind you that I'm recording these, and this might be a good one to review. Only because there are so many pages on this one that you need to memorize.
Okay.
You need to memorize. In fact, let's just look at it. Hold on before I go. Need to memorize everything on this page, including all 3 dimensions of these 2 special triangles. You need to memorize everything on this page. Not what I have circled, but everything, whoops, not that. It's nice to know that 90 is the same as pi over 2, or that 180 is the same as pi. So memorize everything you see on this page.
Okay.
Memorize these 2, everything you see on this page. This one is cosine down here. Y is cosine of x. And we didn't really get to any, you didn't have any problems that required you to memorize these, but you will, I would think. That's coming up. And same thing with the cofunctions. You didn't have any problems that required you to memorize those today, but that's part of what you want to memorize in Trig. All right. And you know how to retrieve these